Good evening to all. My name is Ganesh Shankar Bhandari and I am here to take the live session for NPTEL course Municipal Solid Waste Management taught by Professor Ajay Kalam Dad. Okay, so in the live session, first we will go with the revision of the last week lectures. Then we will solve some question problems based on the last week lectures. Okay, so these problems can help you solving the assignment in the NPTEL course. Okay, so we will start with the last week lectures. Okay, so we were talking about disposal of solid waste, which includes the landfill of the remaining solid waste left over after different treatment processes like metal recovery, anaerobic digestion, or composting process. So after that, whatever the waste is left, whatever the waste residue is left, so that has to be landfilled. And in the previous lectures, we talked about the criterias for selecting a landfill sites and what are the basic requirements for to create a landfill. We have to create a proper system to collect the leachate and gases like that. So in previous week lectures we learned about the collection system for leachates. Okay, so in this week lecture we will talk more about the gas collections, landfill gas collection, which has been generated during the from the landfill sites after the landfilling of the municipal solid waste. Okay, so there has to be a proper landfill gas collection and treatment systems at every landfill. So basically, this landfill gas is termed as LFG. Okay, so what is the generation mechanism of this LFG? So these are the emissions governed by gas generation mechanism and gas transportation mechanism. There are three primary causes which promotes the formation of these LFG. First one is volatilization, then biological decomposition, and third one will be chemical reaction. So these are three different primary causes which influence the generation of the landfill gas during the landfilling process. So what is volatilization? Generally, municipal solid waste contains many different types of organic compounds, and some of these organic compounds are tends to be volatile at a certain temperature. Like if we talk about the inorganic compounds like CH4 gas, or maybe there will be acetone or ethanol, like these different types of organic compounds has a different volatilization temperature. Like acetone has a volatilization temperature of around 70 to 80 degrees Celsius, or ethanol has a volatilization temperature of around 90 to 100 degrees Celsius. So organic compounds in the landfill volatilize until the equilibrium vapor concentration is reached. Okay. Then this process is accelerated when biological activity increases the temperature of the waste mass. As we have already talked, that these compounds have a certain volatilization temperature. Okay. So until unless that temperature has not reached, these compounds are not going to be volatile. So temperature will get increased due to the different biological activities happening inside that landfill. Okay, then biological activity increases the temperature of the waste mass, and rate at which compounds volatilize depends on their physical and chemical properties. So Henry's law determines the extent of volatilization of a contaminant dissolved in water, because as we already know, there are two different factors which decide the volatilization of any compound. One is temperature, then second one is pressure. Okay, so if the vapor pressure of the compound has become greater than the surroundings, okay, then that compound is going to get volatilized. Otherwise, that will remain suppressed due to the atmospheric pressure applied on that particular compound. So Henry's law is a base. decides the extent of volatilization of a contaminant dissolved in water, and the law states that the amount of any gas that will dissolve in a given volume of liquid at constant temperature is directly proportional to the pressure that the gas exerts above the liquid. So mathematically we can write it as HA into XA. So here PA is the partial pressure of the compound which is going to be volatile. Then HA is a Henry constant for particular compound. Then XA is the mole fraction of compound A in the liquid phase in equilibrium with the gas phase. Then second one is biological decomposition and chemical reaction processes, which is also responsible for the uh, volatilization of the different organic compounds during the landfilling process. So here we can see a graph. There are four different phases which varies according to the time. So in first phase there will be aerobic digestion process, and there will be generation of oxygen gas mainly. Okay, and that then second, third, and fourth phase are basically anaerobic digestion processes in which there will be very less amount of oxygen present inside the landfill sites for proper reaction. So it will uh, during that anaerobic digestion process, what will happen? Whatever the oxygen present inside that landfill sites, it will convert the organic compounds into the carbon dioxides, and after the conversion of carbon dioxide, there will be the methanation process, nitrogenation, and hydrogen evolving process will be there. So after a time period of around 4 to 5 years, there will be less carbon dioxide generation as compared to the methane gas. So that gas can be reused as a fuel material if we are able to capture that landfill gas. Okay, then there are different phases of decomposition during the biological or chemical transformation process. First phase is initial adjustment phase, or we can say aerobic phase. So in this aerobic phase, the organic compound is going to react with the water content, and it will convert into the glucose part, and it will evolve the hydrogen gas at the same time. And these all things will happen due to the microbial actions inside that landfill site. Then second phase is acidogenic phase. So in this phase, the glucose generated during the first phase, or we can say aerobic phase, it is going to get converted into the acid compounds. So the pH of the leachate, it starts to drop due to the presence of organic acids and elevated levels of CO2. Okay, so we can say in the aerobic phase, we can maintain a pH at around 7 or 8, or we can say 9, 10 around. But during the acidogenic phase, due to the reaction which is happening for the conversion of glucose compounds into different types of organic acids, like we can say acetic acid or formic acid or glutonic acid. So these acids will create a acidic pH environment in the landfill sites, and that will that will help in the drop of the pH of the leachate, which we are collecting at a landfill sites. Then third phase is acetogenic phase. So in this phase, the production of significant amount of organic acids will be there, and CO2 will be the principal gas which is going to be generated during this acetogenic phase. And the pH of the leachate will drop significantly, and COD and BOD of the leachate increases significantly. Chemical oxygen demand and biological oxygen demand will get increased. Many essential nutrients are also removed in leachate, and if the leachate is not recycled, the essential nutrients will be lost from the systems. Then the fourth phase will be the methane fermentation phase. So in this phase, what will happen? Whatever the acids has been generated during the first, second, and third phase, so that acid is further going to decompose into the methane gas. So what will happen? The pH will again rise to increase, or we can say the pH will change from the acidic value to the neutral value, because the acidic content in the leachate or we can say the landfill site is going to get decomposed into the methane gas and CO2 gas. So in this phase, the amount of CH4 gas will get increased compared to the CO2 gas. The gas generated during this phase process will contain around 55 to 60% of methane gas, and on the other hand, the CO2 amount will be on the lower side at around 40 to 45%. So, due to the higher content of CH4 gas, the gas generated during that process can be used as a fuel source if we are able to properly capture that gas. So, the we require a proper setup for the capturing of this gas generated during the methane fermentation phase. Then there is last phase is maturation phase. So the readily available organic material will going to be converted into the CH4 and CO2 gases, and rate of landfill gases generated diminishes significantly. Then there are different factors which affect the generation of the LFG, like waste composition, temperature, moisture content is has to be optimum level, pH level. It has to be at neutral to generate the CH4 or CO2 gases in a proper amount. Then what are the atmospheric conditions are there? Landfill cover, what type of landfill cover we are using? Then what is the density of the waste, and what is the age of the waste material. We have started the landfill around 5 years ago or 10 years ago, because with that with the increase in the year of the landfill site, the composition of the LFG will uh, get we can say the composition of the LFG can vary according to the year of the landfill site. Then we have to create a proper transport mechanism for the capturing of these landfill gases, or we can say the transport of landfill gases occurs by the two principal mechanisms. One is diffusion and second one is advection. So how these LFGs are moving inside a landfill sites. So based on these transport mechanisms, we will develop a proper system for the capturing of these landfill gases. So first one is diffusion. The diffusion flow of gas is in the direction in which its concentration decreases. So as we know, according to the thermodynamic principle, anything will move from higher concentration to the lower concentration part. So the diffusive flow of gas is in the direction in which its concentration decreases, and concentration of a volatile constituent in the LFG will almost always be higher than that of the surrounding atmosphere. Concentration gradient between the surface and the interior of the landfill. So there has to be a concentration difference between the landfill and the surface, so that the LFG can move upward in the landfill site, so we can properly capture it, and thus promotes the migration of vapors to the surface. Geomembranes in landfill covers will significantly reduce diffusion, because the geomembrane prevents gases from diffusing to atmosphere. But the trick is that we have to prevent that diffusion of these gases, or we can say migration of these gas vapors into the surroundings, because we have to capture them. We cannot leave them in the surroundings. Okay, so we have to provide a proper geomembrane layer on the landfill as a landfill cover, so that we can prevent the diffusion of these gases into the surrounding atmosphere. Because why we don't want to the diffusion of these gases into the surroundings, because these gases majorly contains around 40% of CO2 and 55 to 60% of CH4 content, and these two gases are the makes the higher part of the gas emission, so we don't want to leave them in the environments. Then advection, the rate of gas movement is generally orders of magnitude faster for advection than for diffusion. Then gas will flow from higher pressure to lower pressure regions. In a landfill, advective forces result from the production of vapors from biodegradation processes, chemical reactions, compactions, or an active LFG extraction system. So there are different factors which can affect the transport mechanism of this LFG. First one is permeability. The permeability of waste has a large influence of gas flow rates and gas recovery rates because gas will move from one pore to another pore. Coarse grain waste exhibits large value of gas permeability and more uniform gas flow patterns, and fine grained slow. So heterogeneous waste are characterized by small value of gas permeability and gas flow pattern that are not uniform. So there has to be a proper amount of porosity, or we can say permeability, inside a landfill sites for the proper flow of the gases inside a landfill site. Then there are some geologic conditions. Geologic conditions must be determined to estimate the potential far offsite migrant of gas. Then depth of groundwater, the water table surface act as a no flow boundary for gases because gases are not going to diffuse inside the water because it already has a vapor pressure higher than the gases generated in a landfill site. During design process, well construction requirements and the potential for water table upwelling should be evaluated. That is the upward rise of the water table towards a vacuum well screened in the unsaturated zone. Then what are there are different types of man-made features, like in some instances underground utilities. Hello. Underground utilities such as storm and sanitary sewers or the backfill that surrounds these features may produce short circuiting of airflow associated with an active landfill gas collection system. Then landfill cover and liner systems, as we have already discussed, we have to provide a proper geomembrane as a landfill cover so that we can uh, decrease the diffusion of these landfill gases into the surrounding atmospheres. Then barometric pressure, the amount of gas escaping from a landfill surface changes as barometric pressure changes. So passive LFG collection system increases in atmospheric pressure and causes a decrease in gas flow from a landfill because the pressure differential between the inside and the outside has decreased. So that will create a huge problem during the collection of these gases. So, active gas collection system, atmospheric air intrusion through the landfill cover during periods when the barometric pressure is rising. So, we have to maintain that barometric pressure for the proper collection of these LFGs from the landfill side. Then there are impact, relevance, and trends of gas phase emissions from landfills. So, there are some factors. Then design of landfill gas system. So for the proper capturing of these landfill gases from a landfill site, we have to design a proper landfill gas system. So first thing, design of gas wells. Performance question for wells is defined as meter cube per hour per millibar. So large diameter can be at up to around 900 mm, vertical 10 to 30, and horizontal 10 to 15. So gas wells can be divided into this structure: topsoil, then subsoil, surface water drainage system, cap sealing layer, gas drainage layer, waste fill. Yeah, Omawani, you want to say something? Okay. Okay. So then coming to site contaminant, temporary capping, there's our daily cover, then there is permanent capping, which keeps out water and air and keep in gases and odors. Then site lining to contain waste, leachage and gases. Uh, then we have to optimize the gas well operations, like we have to minimize the gas velocity, gas approaching the well make well diameter large. Then for maximizing the effective we have to maximize the effective length of the gas well. Uh, so for maximizing this effective length, we can make the gas well deep and we have to keep it dry. And then provide contingency measures. There are flexible connections, movement joints at well heads. Then design of pipe work. Pipes is specified by the outer diameter and either a pressure rating or standard diameter ratio. So for landfill gas, typical pipes are 6 bar or SDR 17.6. It can defined as OD and wall thickness. So OD has to be around 17 mm and then wall thickness is 6 mm. Then gas flow always gives pressure losses. The loss in pressure for gas flow rate is defined as P equal to 60,000 into Q square upon ID to the power 5. So there is a rule of hundreds which is defined to for the gas pipes, that is the gas pipe flow should be around should be able to control a flow of around 100 meter cube per hour flow in 100 diameter pipe, that is outer dia. Then 100-meter long gives 6 millibar loss. Okay, so there is a pressure loss rule which is known as rule of hundreds, that is defined as 100 meter cube per hour flow in 100-meter dia pipe having 100-meter long gives only 6 millibar loss. Then coming to gas collection system, there are different types of gas collection systems. One is passive gas system. So in the passive gas systems, there has to be provided a gas collection pipe inside the landfills above the waste. Okay, so this gas collection pipe will be having some holes inside this gas collection pipe so that gas can purge inside that pipe and it can be easily vent out on the upper layer of the landfill side. So passive collection system can be installed during the active operation of a landfill or after closure of the landfill. The collection wells are typically constructed of perforated or slotted plastics and are installed vertically throughout the landfills to depth ranging from 50% to 90% of the waste thickness. It may also include horizontal wells located below the ground surface to serve as conduits for gas movements within the landfill. Then there is one more gas collection system which is known as active gas system. So in the active gas system, active gas collection system includes vertical and horizontal gas collection wells similar to passive collection system. Wells in the active systems have valves to regulate gas flow and to serve as a sampling port. Sampling allows the system operators to measure what amount of the gas generation is there, what is the composition of the gas, then what the pressure is coming, so we can control the pressure, because we have already discussed the gas will move from the higher pressure to the lower pressure side. So we can control that pressure system in this active gas system. Then vacuum or pumps to move gas out of the landfill and piping that connects the collection wells to the vacuum. So we can generate a vacuum system upper on the upper side of the well, so that due to the vacuum generated at the upper side, the pressure of the gases will be on the higher side in the landfill side. So the gases will move from that side to the vacuum side, so that we can easily collect the gases generated during these landfill sites. Then the size, type and number of vacuums required in an active system to pull the gas from the landfill depend on the amount of gas being produced. Then how is an effective gas system designed? So an effective active gas collection system incorporates the following design elements like gas moving equipment including vacuums and pipings, which should be capable of handling the maximum landfill gas generation rate. Like we have already discussed the rules of 100, it can accommodate a flow rate of around 100 meter cube per hour in a 100 OD in a 100 outer dia with a 100 at a 100 length, and a pressure loss should be not more than 6 millibar. Then collection wells placed to capture gas from all areas of the landfill. Then the number and spacing between each extraction well depends on what is the waste type which has been landfill inside that site, depth of the extraction well, compaction, pressure gradients created by the vacuums, then moisture content of the gas. Then the ability to monitor and adjust flow from individual extraction wells include valve, pressure gauge, condenser, and a sampling port at each collection valve for proper monitoring of pressure and measuring gas generation. Then connection of elements of a landfill gas extraction installation. Gas extraction wells and horizontal pipes can be connected in one or two ways. One is collective headers. Then individual wells and horizontal headers are connected to the main header, so that as we can see, we have connected different land. These are the collection extraction wells. Then these extraction wells are connected through this pipe. Okay, and this pipe is connected with all of the extraction well, so that we can collect the gas from maybe here. Okay, so individual wells and horizontal headers are connected to the main headers which supply gas to the collection station. Gas extraction wells are linked to several collective headers of 100 to 160 diameters. Then there has to at last there has to be a gas collection station. The gas collection station is comprised of the following units: central collectors connected to pipeline to transmit gas of the landfill, then blowers to extract gas from the landfills, filters to remove solid particles from the gas, uh, reservoirs where condensate is removed from the gas, then instruments for control of gas extraction and transport, measuring and control equipment. So why are emission monitored at landfills? So landfill gas emissions may be monitored for one or more of the following reasons. First one is landfill gas control system, because we have already discussed it will take around 3 to 4 years at least to generate the proper amount of the CH4 gas content in a landfill gas. So we have to frequently monitor the landfill gas emissions from a particular landfill, so that whenever the amount of CH4 is going to get higher in the these LFGs, okay, so that we can use it as a fuel source to determine the general composition and volume over time of air contamination emanating from the landfills. Okay, so with the help of this, we can also determine the general composition, which is going general composition of the gases to prevent the air contamination with via CO2 or CH4 gases. Emission rates, estimates, or monitoring may also be used to assess whether it is technically and economically feasible to recover and use the landfill gas for energy production. Because for the LFGs to be used as a proper fuel source, the amount of CH4 gas has to be at minimum of around 55 or 60% of the total gas composition. So for that also we have to frequently monitor the gas collection systems. Monitoring of gas that originate from landfill falls into the following five categories: soil gas monitoring, near surface gas monitoring, emission monitoring, ambient air monitoring, and then indoor air monitoring. So there are some key features for different types of landfill monitoring of different types of landfill gases. Then here comes direct methane measurement. So, landfill methane measurement is the direct measurement of the methane emission from landfills. There are four ways to measure landfill methane directly. Are one is flux chamber testing, plumb measurement, and dispersion modeling. So, in the flux chamber testing measures methane flux, that is mass emission per area at points on the landfill surface using flux chambers. So, here is a typical diagram of a modified flux chamber. The flux sampling methods are generally standardized, but there are no industry accepted standardized methods for the exploration of site-wide emissions. Okay, so that can vary according to industry. Different industries have different SOPs for the flux chamber testing of a landfill site. Then Another one is plumb measurement. Plumb measurement methods use ground-based optical sensors to measure the methane plumb coming from the landfill, and those plumb measurements are then used to calculate the landfill's methane emission rate. Then air dispersion modeling can be used to determine emission rates from the landfills. This method monitors on-site and or downwind methane concentrations using a dispersion model to calculate methane emission from the landfill. So there are some models on based on which we can design a landfill gas modeling, like zero order decay model or first order decay model. Then there is modified first order model, land. Uh, then there is land GEM model. So there has we have to take some assumptions for creating different types of models. Okay, and there are various factors which affect these during the which affect the calculation of these models. So in the different areas, different types of model has to be calculated, based on which we can decide the based on which we can properly design a landfill gas collection system at a landfill site. Then landfill gas contaminants and their removal. So direct reuse of collected raw gas. Raw landfill gas is impaired by gas contaminants such as hydrogen, sulfide, siloxanes, moisture, etc. But um, there are some contaminants are coming like hydrogen or sulfide. But what we need as a fuel source, we generally need amount of 55 to 60% at least CH4 gas inside a gas to use it for proper using it as a fuel source. So these contaminants has to be removed before going for the use of the landfill gas as a fuel source. So landfill gas needs to be treated due to its relatively high content of contaminants. The treatment should be comprised of the following stage. So in the first stage, we will do some primary treatment processes consisting of the removal of solids and liquids. So because we are creating the vacuum at the upper side of the uh, landfill gas collection system for the proper removal of the landfill gases from a site. Okay, so due to that creation of vacuum, there are high chances that some amount of solids or liquid or moisture content can also come inside these gases due to the higher vacuum generation at the upper side. So those solids and liquids has to be removed and gas has to be dried properly. Then stage second, which is also known as advanced treatment process, which will consist of the desulfurization, because if we are not going to desulfurize the gas, so what will happen during the burning of these gas, it will create the SOx emissions, and that is hazardous in nature. So then we have to properly desulfurize the gas before the use of these landfill gases as a fuel source. Then removal of organic silicon compounds, then removal of other gaseous contaminants such as hydrocarbons and ammonia. And the type of gas treatment used is dependent on the technical and economic constraints. Okay, then coming to the primary treatment, it reduces the amount of contaminants in the landfill gas using simple physical process operations. So main contaminants which are removed from during the primary treatments are water, which is also referred to as condensate, and particulates, which is solid particles coming inside that landfill gas. So water or condensate can be knocked out with the presence of liquid water in landfill gas pipework can have a detrimental effect on plant performance. Then accumulation of water reduces the space available for gas flow and raises the pressure loss. Depending on the source of the gas and the application of proposed use of the treated landfill gas, three components can be treated: liquid water capture, foam removal, or vapor reduction. Then for the removal of the siloxanes inside these landfill gases, the at landfills, low molecular weight siloxanes volatilize into landfill gas. When this gas is combusted to generate power, such as in gas turbines, boilers, or internal combustion engine in the industries. siloxanes are converted to silicon dioxide, okay, SiO2, and that SiO2 is going to get deposited on the surface of the exhaust pipes or the pipes which is carrying the gases. Okay, so that the deposit of these this SiO2 compound on the wall surfaces is going to choke the entire system, and that will create a huge problem during the operations in the gas turbines or boilers. Then evidence of siloxanes in landfill gas is found in the form of a white powder in heated gas turbine components. So the key methods used for siloxane removals are adsorption on activated coal, adsorption in a liquid hydrocarbon mixture, gas cooling with concurrent water knockout. A gas may be cooled down as much as to around minus 70 degrees Celsius, resulting in 99% siloxane reduction. Then there are some advanced treatment processes. Advanced treatment can be defined collectively as secondary treatment in which remove generated emissions like H2S, siloxanes, ammonia, aromatic hydrocarbons, and halogens. So for sulfide removal, hydrogen sulfide is an extremely toxic and flammable gas which is harmful to the environment. Under temperature, hydrogen sulfide reacts with steam to produce sulfuric acid, which has a significant effect on the useful life of a LFG plant. Because sulfuric acid is highly corrosive in nature, so that will affect the entire life of the LFG plant. A comparison of the economics of various methods of landfill gas desulfurization is shown below. So there are different methods which can be used for the removal of the sulfides from these LFG gases, like biological desulfurization treatment with iron chloride. So iron chloride is going to get converted into the FeSO4, and which is uh, which has a very lower dissolution in the water. Then water washing, it will convert the H2S gas into the H2SO4, and H2SO4 can be collected as a liquid. Then activated carbon, iron oxide or hydroxide treatment, or sodium hydroxide treatment. Then there are other landfill gas contaminants, like a landfill gas may also contain the following other contaminants like ammonia or aromatic carbons, hydrocarbons like benzene, toluene, ethylobenzene or xylene, or there will be some there should be some halogens also. These contaminants are usually present in landfill gas at concentration below the detection level. The concentration of ammonia is below 0.1 milligram per meter cube. That of aromatic hydrocarbons are below 1 milligram per meter cube, and halogens are below zero point 0.1 milligram per meter cube, facilitating immediate use of gas without the need for any additional treatment. Generally, we don't have to treat the landfill gas for these contaminants because these are already lower inside these LFG gases. But in some cases, if they are going to be on the higher side, then we have to go for the proper treatment processes for the removal of these contaminants before going for the use of the landfill gases. Then landfill gas energy technologies. So these are like just we can use the landfill gas as a fuel source for generating uh, uh, the steam with the help of a boiler, and that steam can be used for the generation of the electricity inside a ener- uh, ener- fuel to energy conversion power plant. Then we can go for the biomethane production. Biomethane is a gaseous fuel with physiochemical properties similar to those of natural gas, which makes it possible to inject it into the gas grid. LFG can be upgraded to biomethane by removing carbon dioxide, which is at around 40 to 50%, and trace contaminants such as ammonia, hydrogen sulfide, and siloxane. So, in the biomethane, the content of CH4 has to be at a higher content of around 95 to 96% at least. So, it can be considered as a biomethane. So for the proper composition, we first have to remove the carbon dioxide, which is in the major composition around 30 to 40%, and trace contaminants such as ammonia, hydrogen sulfide, and siloxanes. Two following technologies for CO2 removal from landfill, gas are employed to improve the energy value of the fuel. One is pressure swing adsorption, physical and chemical absorption, which can be done with the help of different types of liquids, or we can go for the carbon absorption process, then membrane separation and cryogenic treatment. So in the cryogenic treatment, we can apply uh, a temperature of around minus 70 or minus 100 degrees Celsius. So the CO2 gas is going to get converted into the liquid form, and it can be easily removed from the uh, uh, LFG gases produced during the produced in the landfill sites. The processes are different not only in terms of utilized techniques but also in terms of the achievable gas quality, the processing behavior, and the experience with which they have been used in landfill gas processing. So, the overview of CO2 removal process: with the help of adsorption, we can get a final methane content of more than around 96%. Similarly, in physical adsorption, also we can get a final methane content of more than 96%. While in case of chemical absorption, we can get a final methane content of more than 99%. While in membrane separation process, we can get a methane content of more than 80%. Uh, and in case of cryogenic process, we can get the highest purity uh, due to the conversion of the CO2 into the liquid form, while CH4 will remain into the gaseous form, and we can get a purity of around 99.9% CH4 in the biomethane gas. So there are some reasons for landfill gas controls. The following is a list of common reasons for controlling the gas produced by a landfill. It can prevent air pollution, as we have already discussed. If the landfill gases is going to uh, released in the environment, it will create a major burden on the greenhouse gases, like because it majorly contains CH4 and CO2 around 99%. So it will contribute to the greenhouse gas emissions. Then it will reduce. So we by preventing uh, by preventing the release of these gases into the air, we can prevent the air pollution. Then reduce hazards due to off-site migration. Then prevent damage to the landfill cover slope stability. It can control the odor, energy, or with the help of the landfill gas control, we can also recover the energy and prevent vegetation distress on the land on a landfill site. So now coming to the next lecture. Okay, so we have talked about the landfill gas generation process and how we can design a proper system for the collection of those landfill gases, and how we can uh, refine them for for the further use in for further use of those gases as a biofuel. Then coming to the design of landfill. So we have to design the landfill uh, with some proper keeping in mind some factors like how much solid waste is generated, how much up to how much height we can fill that landfill sites. So we will go with some examples, like estimate the required landfill area for a community with a population of 31,000, assuming the following conditions. So we have to design a landfill area for a community which has a population of around 31,000, and solid waste generation is around 2.9 kg per capita per day, and compacted specific weight of solid waste. So we have already compacted it, and it has a density of around 475 kg per meter cube. Average depth of compacted solid waste is 6 meters. So we cannot go more than 6 meter height of the landfill. So first, we have to calculate the amount of the solid waste generated in 1 year. Okay, so we can calculate it easily generation rate, and for per day area requirement will be at around 190 meter cube per day. Okay, so we required a area of around 190 meter cube per day, and we have already discussed we have to design a landfill for at least for landfilling of waste for at least 10 to 15 years. Okay, so here we can calculate the design of a landfill for 1 year, so it will come to 1.15 hectare per year. Okay, then additional land is required for a buffer zone, office and service building. So that allowance has to be considered at around 20 to 40%. So based on this, this will also include up to 1.15 hectare per year, and it will include around 2.30 hectare per year for the as a buffer zone. So it will come to around 1.15 plus 2.30. It will come around uh, point 1.15 plus 0.23. Okay. Then example 2, determination of density of compacted solid waste without and with waste diversion. It is similar to the previous problem, but in that case we have to first calculate the proper compacted volume on the basis of uh, the specification of the waste which is given. Okay, then we can calculate it. Then determination of waste to soil ratio. These are some examples. Then coming, yes. Present status of legacy in waste and its impact on environment. So there are two major challenges of solid waste management in our cities or towns. First one is managing the continuous flow of solid waste on a daily basis. Then dealing with the legacy of neglect, which has resulted in garbage heaps having been built up at dump sites that were meant for waste processing and landfills. The sites for landfills were originally located outside of the cities, but as the cities have expanded, the dump sites are now almost in the cities. Like Delhi's open dumps at Gazipur, which is having a height of around 69 meters. Then Okhla 55 meters high, Balsava 56 meters high. Example are all much higher than the permissible height limit of up to 20 meters. It is estimated that more than 10,000 hectares of urban land is logged in these dump sites in India, because we are not processing the waste before going for the landfill. What we are doing, we are directly going for the landfill of the waste generated in these cities. Landfill sites generate methane and other landfill gases which contribute to global warming. They also produce leachate, which pollutes groundwater. Then present status of legacy in waste and continue. Many municipal authorities across the country are opting for capping as a solution to the legacy of mixed waste, which is not in the first option in the order of priority for environmentally safe legacy waste management 2016 rule. And then Government of India has notified the solid SWM rules 2016 for proper and effective management of municipal solid waste. Under the 2016, following provision has been made to manage all dumps of MSW, which is Rule 15. Duties and responsibilities of local authorities and village panchayat of census towns and urban agglomerations. The local authorities and panchayats shall investigate and analyze all old open dump sites and existing operational dump sites for their proper potential biomining and bioremediation. And whosoever, wheresoever feasible, takes necessary action to biomine or bioremediate the sites. In the absence of potential of biomining and bioremediation of dump site, it shall be scientifically capped as per landfill capping norms to prevent further damage to the environment. So biomining, it is like we are providing the proper system in we are providing a proper system in these landfill sites to collect the biogases from there, or we can say the leachate contents from there, and we are going to reuse that leachate content and gases produced during the dump from these landfill sites. Okay, or if we are not able to biomine these sites, so we have to provide a proper capping on that landfill sites for preventing the further damage to the environment. The bylaws shall apply to every urban local body, outgrowths in urban agglomerations, cantonment boards, panchayat, industrial and institutional townships, railways and defense establishments. So bioremediation and biomining of old municipality dump sites, we can see this like mining of legacy waste, stabilized waste, biocultures and aeration, then screening of waste has to be done to differentiate them in different sizes. So the particles having size lower than 150 mm, it will having size greater than 150 mm. It will mainly contains the bricks, coconut shell, footwear, clothes, large plastics. So these things can be separated with the help of a density separators, and then we can go for the recycling of these uh, inert waste, like we can make RDF from coconut shells or footwear or clothes. Then plastics can be recycled, and containing bricks can be reused in the road making process, while the waste from 30 mm to 80 to 100 mm, these waste will be shredded as per the requirement or industry need, and that can be reused, further reused for RDF, recycling or road making processes. Then waste lower than 4 to 6 mm will mainly contain the bioearth or good earth, or we can say the organic materials. So these can be provided to the farmers or land, or it can be landscaping or reused as a soil conditioner. Then processing equipment for processing of legacy waste. The major equipment that would come in use would fall under the following heads of processes, like excavation, shredding, screening, followed by air classification and ferrous separation. And as per suitability and requirement, the appropriate choices should be made. So screens, different types of screen can be used, like trommel, vibratory screen or disc or star type screen. Then handling equipments are needed, like loader, conveyors or forklifts. Then process of bioremediation and biomining. So there is a schematic representation of biomining through excavator by making windrows. So excavator to dig to 2.5-meter deep trenches, then hand pick large object, make windrows from remaining waste, mist spray bioculture 5% of cow dung, mix in water and spray on the waste. So what it will provide? It will provide the microorganism on the side, and we have to turn the windrow every 2 to 3 days, and after 20 days we have to do the screening. So what we are creating with the help of this process, we are creating the compost for the soil. Okay, so that can be reused as a fertilizer in the agricultural process. So, schedule 1, closure and rehabilitation of old dumps. So, solid waste dumps which have reached their full capacity, or those which will not receive additional waste after setting up of new and properly designed landfill, should be closed and rehabilitated by examining the following options, like reduction of waste by biomining. If we can reduce the waste by biomining process and waste processing, followed by placement of residues in new landfills. Then, or we can cap the solid waste cover, capping with solid waste cover or solid waste cover enhanced with geomembrane to enable collection and flaring or utilization of greenhouse gases. Capping as in second above, with additional measures in alluvial and such as cut-off walls and extraction wells for pumping and treating contaminated groundwater. Then excavators, okay, we can use different types of excavators, or we can hand pick the different types of objects which can be recycled, like rocks, coconut shells, long pieces of clothes, or large plastic bags. So these work can be done by the rag pickers, which can be resold by these rag pickers for creating some economy from these dump sites. Then windrow management, the organic waste contains in these landfill sites can be managed with the help of the windrows for creating the compost to be reused as a fertilizer during agricultural processes. Then use of screen fractions, okay. Then process management. So space management is necessary for all waste establishing method. Management of space is the biggest challenge as aeration, stabilizing and screening mostly needs to be done within the boundaries of an already overloaded dump site. So we have to properly manage the space at that dump site for proper biomining process. On-site earth movers operators often come up with the best solution, so seek their opinions. Then every dump site poses a case-by-case challenge, but there is no above-ground dump that cannot be successfully remediated and biomined. Then there has to be provided a proper leachate management system. Then fire control and safety issues has to be kept in mind. We have to provide the proper equipments for controlling the fire because these dump sites will produce the methane gas due to methane gas, and methane gas is highly flammable. So we have to properly control the uh, fire, any hazards which can cause due to the fire at that dump site. Then okay, there is nothing use of recovered space. So there are some cases of biomining in India are like in Indore, there are some legacy dump site which are used for the biomining purposes. The 100-acre dump site in Dev Guradia was home for 15 lakh metric tons of legacy waste that accumulated over decades. The recyclables obtained from the biomining and MP government has done some biomining process at that dump site, and the recyclable which were obtained from the biomining process from this dump site were used as a for recyclable for creating recyclable polythene which was used for making roads. The soil recovered was used for refining the ground. Then the construction and demolition waste were recovered and sent to produce building materials. Indore treats 15 lakh metric tons of waste in 3 years with the help of the biomining process, and they have cleared that dump site. So previously it was looking like this. Now it looks like this. So, case study second, biomining of Kumbakonam, which is based in Tamil Nadu. Municipality reclaimed 12 acres of prime land that was laid waste after being turned into a garbage dump yard over the years. The status of Kumbakonam dump site out of 1,31,250 meter cube, more than 1 lakh meter cube has been processed and successfully disposed, and 7.5 acres old dump site with garbage more than 5 acres has been reclaimed. So until yet they have reclaimed around 70% of the dump site. The project cost estimated to be rupees 7 crore is being viewed favorably against the cost of the land reclaimed. The plant achieved 0% reject, which means none of the aggregates are considered as reject and dumped back into the sanitary landfill sites. So previously that site was looking like this. Now we can see the change in the dump site. Okay, so these were all about the landfills. Now we will go with some questions, okay, based on the this week lectures. Okay, so first one is, what is or are the primary cause of landfill gas generation?
All the above. D.
Yes, all of these are correct. For the all of these are the primary cause for the landfill gas generation, like volatilization process, which majorly generate the CH4 or CO2 type gases. Then biological decomposition, that can be two types: aerobic decomposition process or anaerobic decomposition process. So during the aerobic decomposition, there will be more amount of formation of CO2 gas, while in anaerobic, the major amount which will produce during the anaerobic will be CH4 gas. Then there are some chemical reactions which are also cause the landfill gas generation in these landfill sites. Okay. Then in which of the following phase of decomposition does the pH of leachate drop? So in the beginning, pH is at around neutral position, or we can say in some acidic conditions, or around 8 to 9. So in which decomposition process the pH of is going to drop at acidic conditions like 3 or 4 pH range?
B and C.
Yes, during acidogenic process and acetogenic process. So during these two processes, the pH of the leachate is going to be dropped because due to the formation of different types of acids, due to the decomposition of the organic compounds, like in the aerobic phase, in the presence of oxygen, the organic compounds is going to get converted into the glucose part. Okay. And then in the second and third phase, which is known as acidogenic or acetogenic phase, the glucose is further going to be decomposed into the acetic acid or carboxylic acid, or we can say different types of fatty acids, and it will help to decrease the pH of the leachate at in the acidic condition. While in the fourth one, during the methane fermentation phase, the pH of the leachate will again going to get increased back to the neutral pH value. Okay. Then third one, which of the following factors affect LFG generation?
D. Uh, all these. All
Yes,
of
all of
these.
these. Because temperature is going to create a major part during the LFC generation, because if the temperature is at has in the landfill site has reached to around 80 to 90 degrees Celsius, so there would be some compounds which will be having the volatilization point at around 90 or 100 degrees Celsius, and moreover, on the other hand, there will be some pressure also. Okay, so due to that increased pressure, the temperature, the volatilization temperature of the compounds can vary. Okay, so the temperature is going to create a major factor during the LFC generation. Then pH value, yes, due to that pH value, the microbes organism processing will get affected. Then waste density is also a major factor during the LFG generation. Okay, which among the following correctly fits to define the rule of hundreds in pipeline design, which is used in landfill gas generation systems?
B.
B or D?
Second one.
Yes, second one. So we have to design a pipeline according to rule of hundreds, defines a flow, which defines a flow of 100 meter per cube hour in a diameter of pipe around 0.1 mm, zero point 0.1 meter, and length is 100 meter, and pressure loss should not be more than 6 millibar during the whole process. Okay, so that is rule of 100 for pipeline design in a landfill gas generation system. According to SWM rules, how many years should pass before a clear dump can be reused for a habitation purpose?
15 years.
Yes, it is 15 years. For landfilling, we have to go for at least 15 to, we have to design a landfill site so that we can landfill the waste at least for 15 to 20 years. And after the closing of that landfill site, okay, we have to wait for at least 15 years for creating the habitation at that site. Okay. Identify the correct schematic representation of biomining through excavator by making windrow.
Last one, sir.
Yes, that has to be last one. We will go with excavation, then we will hand pick the large objects for creating a proper recycling process. Like we will separate out the plastic, demolition waste, coconut shells, or other large items. via hand picking, and that will go for the further recycling processes. Then we will uh, make the windrows with the help by using the separated waste which is having a size not more than uh, 5 or 6 mm. Then we will spray the mist spray, or we can say bioculture will be sprayed on these windrows. Then after 2 3 days we will turn the windrows for proper aeration. And after the 20 days or 25 days is completed, that windrows the waste presented in these windrows is going to get converted into the compost material, and we will do some screening process, and that under screened material will be used as a compost material in the agricultural process. Okay. Then factors affecting LFG transport mechanism.
A, B, C.
Yes, A, B, C. All of the factors are there which affect the LFG transport mechanism: permeability, then geologic conditions, landfill covers, and liner systems. Okay, so wait, 1 second. Which of the following should be tested from time to time for bioearth, or we can say biomining?
Heavy metals.
Yes, heavy metals has to be tested time to time for bioearth. Okay. Uh, then permissible options for reusing recovered landfill sites after certain years can be.
Uh, the first two, A and B.
Yes, it can be reused for first two for open stadium, or it can be reused for SWM. But third one we cannot use it for flammable warehouses, because after 15 or 16 years also it can generate some minimal amount of CH4 gases from the surface. So we cannot use it for flammable warehouses. Okay. So that is for today. If you wanna ask something, you can ask. You have any doubts, or we can close this meeting.
No, sir, no doubts.
Okay, okay. Thank you, Anil.
Thank
Okay.
you.